multi-layer perceptron. So far we've seen a single perceptron and its behavior, and one input and one output. That's typically called a single layer perceptron. Now there are multiple layer perceptrons as well. And when these are combined with something called back propagation, we'll discuss what that is, it overcomes many of the shortcomings of that single layer perceptron. So what are multiple layers perceptrons? As seen previously, the exclusive OR behavior needs two decision lines to separate the data without incorporating errors. Likewise, there are many problems which need to have multiple decision lines for a good acceptable solution. We saw that as well. So multi-layer or multiple layer perceptrons achieve this task by introducing one or more layers of perceptrons between the input and the output. Okay, and they're also called hidden layers because they're not exposed as such to others. Now each neuron in the hidden layer forms a different decision line. Remember, each neuron creates a decision line. So each neuron in the hidden layer forms a different decision line. And by combining all the lines, decision lines for each of these hidden neurons, we can construct any arbitrary nonlinear decision boundary. That's interesting. So these multi-layer perceptrons are the most basic artificial neural networks, ANNs as we call them, artificial neural networks. And we see them in the diagram here. On the left you have two inputs with a bias, that's called the input layer. And then there are two neurons or perceptrons in the middle as well, that's hidden layer, and then the output layer. A very simple structure. Okay, now artificial neural networks can be trained supervised and unsupervised. We'll see that. A neural network is a massively parallel distributed computing system that has a natural tendency for storing experiential knowledge. Okay, remember experiential knowledge? Something that you learn over time. You make mistakes and you learn. And then make it available for use. So it resembles the brain in two aspects. Knowledge is acquired by the network through a learning process called training. That's how you acquire knowledge. The interneuron connection, the strengths known as the weights or synaptic weights, are used to store that knowledge. Okay. Remember this point. The interneuron connection strengths, the synaptic weights as we call them, are used to store the knowledge. So in this sense, the knowledge in the artificial neural networks is implicit, it is not explicit, and it is distributed. So all of the knowledge is actually designed or rests in the weights, synaptic weights of each of these inputs. As opposed to when you have other systems where you explicitly define your knowledge. So it is not explicitly defined, it is distributed. The advantages? Excellent for pattern recognition. Excellent classifiers, remember groupings between let's say fruits and other data forms. Handle the noisy data very well. What is not noisy data? You have actual data and then something which is added to it, which is not the real data. That's the noise. Okay, you want to segregate them. It's very good at that. It's very good for generalization. Given very large data, you can generalize 2, 3, 4 ways, whatever you want. The drawbacks. The power of the artificial neural networks lie in their parallel architecture. Now this leads to a potential drawback because there's a lack of defined rules to build a neural network for a particular problem. And then you need to consider too many issues as well. For instance, what learning algorithm to use? How many number of layers you need to have? And then number of neurons in each layer, how many? Is there an empirical formula? There's none. How do you represent data? And so forth. So the underlying thing is that the data, the knowledge is implicit and strong dependency on the data itself. And then we mentioned single layer and multi-layer networks. And once again, you can see single layer versus multiple layers. Now, another important thing you need to work out is the direction of information flow or the signal. There are some that are feed forward, input coming in, feeding forward. There are situations in which the information can flow backwards as well, called feedback or the loop. So you have a feed forward, information is flowing in one direction only, recurrent or feedback, where in the loop where the information or signal is flowing backwards, as you can see in the diagram here. One is feed forward only, the other one has a feedback, the loop as well, recurrence. So you can see that it is feeding the output back into some of the neurons. That's called the recurrent networks. And then some are called, another feature is fully connected and partially connected. Another example again, fully connected on the left and partially connected. These are other things that you need to understand. Learning methodology, supervised. Given a set of example input-output pairs, find a rule that does a good job of predicting the output associated with a new input. Unsupervised, same way, given a set of examples with no labeling, group them yourself into sets called clusters. So knowledge, once again, not explicitly represented in neural networks. The knowledge, as I said before, is primarily encoded in the weights of the neurons within the network. So the number of features are a number of features are determined. They determine the use of the number of inputs for the problem in many machine learning applications. So there are a huge number of features. For example, text classification, the number of words, genetic arrays for DNAs, classification, DNA classification range from 5,000 to 50,000. Images, though you used to it 512 by 512, that's the image size. And these large features spaces make the algorithms run slower. And of course, the training takes longer. So the solution is to find a smaller feature set, which is a subset of the existing feature, and get you the results. Training is either supervised or unsupervised, as I said. Learning is simply done through adjusting the weights of the network. That's where the learning is. And that's where the feedback loop comes in. So there is an error between what you want to produce output and what the network is producing. This delta, the difference between the output required versus the produced, is sent backwards, into the system, in the case of recurrent networks, so that the network adjusts the weight to produce what is required. So there's a constant struggle between what you produce, what is the output, and where the weight should be. So if you try and match one particular output, you might lose the other output. So you have to have a balance. As you can see here, weighted sum of the inputs, then activation function, then goes to similarity measure, how good is your output is compared to the required output, and then you feedback this to the system and you adjust the weights. Similarity measurement, of course, tells the difference between the output required and the one that you're producing. The most common way of measuring this in each iteration, called epoch, is the mean squared error. Now, validation. During the training data is divided into different sets, k sets, where k minus 1 sets are used for training and the remaining used for cross-validation. Simple, you've heard this before. A stopping criteria. We can define a low threshold, meaning that you produce an output which is different from what you actually want the output. How small is that data? It will probably never be 0. So you define a minimum value. That way you stop, you say that's enough. And then you will realize that this is why sometimes neural networks or the learning is not always perfect. Another stopping criteria is the number of epochs, meaning what is the maximum number of times the same data can be presented to the network for learning over and over again. Then types of neural networks, several types, and these networks are implemented based on one set of parameters as opposed to the others. And you can see various types as I've shown in the diagram. Each have their own challenges, and so the idea is that to give you an idea that how they are trained, what various types are, and then what is the feedback mechanism by which you adjust the weights to actually represent the implicit knowledge in the neural networks. Thank you very much. We'll see you next time.